colleagues, friends, our two inaugural lecturers, and importantly, their family. Welcome. I'm Ian Martin. I'm the Deputy Vice-Chancellor Academic at UNSW, and it's my privilege to officiate at today's inaugural lecture. In welcoming you to UNSW, I would like to acknowledge the traditional owners of the land on which we stand, the Bidjigal people, and pay my respect to their elders past and present, and extend that respect to any Aboriginal or Torres Strait Islanders present here today. The inaugural lecture has been a long-standing and important tradition of university life. Although it's not been a feature of UNSW life until this year, it marks a very important passage of an individual's academic career to the highest promotion that we have, that of professor. It's not a new tradition, as I've intimated, and the tradition dates back to the medieval guilds. And the tradition goes that after a stipulated period of practicing lecturing and managing disputes, you were formally admitted to the guild with your inaugural lecture delivered to the Regent Master. I quite like that title. And you were expected to put up verbal swords and exchange in controversy. There's an important follow-up point for courtesies. The earliest element, which appeared to be consistent, is some form of celebratory eating and drinking. And that's gone on for a long time. And there's a story of an academic called Gerald of Wales who gave a 3-day inaugural lecture, reading his History of Irish Places Hibernica to all comers. He gave 3 dinners, 1 on each day. He gave the first dinner to the poor and the needy. The second day's dinner, he invited the most senior scholars. And on the third day, he invited the townsfolk. I think this is probably a little excessive. There is another tradition I think we need to look at from the past, and that is a vote of thanks back from our inaugural lecturers. There was a tradition that they were expected to pay for the event. And not only pay for the event, but look after the university for a period of time afterwards. And the Oxford tradition in the early days was that those delivering the inaugural lecture should, for the next 40 days, preside over all disputations within the university. Again, a tradition I think we might need to consider. It would be really good to be able to do that. All parking questions, yours. All joking aside, this is a very, very important part and a passage in someone's academic career, and for me it is a great pleasure to be able to introduce our 2 inaugural lecturers this evening. In reverse order of their presentations, we have Professor Ben Newell, who's an Australian Research Council Future Fellow and Professor of Cognitive Psychology here at UNSW. His research interests include judgment and decision-making, optimality, rationality, insight, and the implicit-explicit distinction in categorization, learning, memory, and knowledge. He serves on a number of editorial boards and has made a very significant contribution already to his profession. Our second speaker, Colin Clifford, is Professor of Psychology and ARC Future Fellow here at UNSW as well. His research focus is vision, how the context of vision affects perception, and how visual awareness might be related to the underlying neural processing that sits behind this. It really is a great pleasure for us to be here this evening, and to start, I invite Professor Colin Clifford to deliver his inaugural lecture.
Thank you very much. So, Ben and I are talking this afternoon about from visual illusions to cognitive illusions, and so my half of the bargain is to talk about from visual illusions, specifically what we can learn from visual illusions. And one can easily access many visual illusions just by Googling visual illusion on the web. So it's something of a challenge to, if you like, give this talk. We've all seen visual illusions. I'm sure we've all seen visual illusions that we'll probably like better than the ones I'm going to show this evening. But these ones are, if you like, relevant to my career and in some cases, as you will see, personal to me. So I hope you'll find them interesting from that point of view. And something of the scientist in me has to try and explain something. While I enjoy looking at visual illusions, I really want to understand them and to learn something about our visual systems, our brains, from these visual illusions. I hope to be able to give you a flavour of that sort of enterprise. So there's an expectation, I believe, to say something about my early years. Don't really have a lot to say. I was young once, rather nerdy with big ears, and maybe not very much has changed really. But one thing, to my mind, that was notable about my childhood, maybe everybody feels this, I don't know, but was the music. I grew up in the halcyon days of punk rock, and it was wonderful. I think it's fair to say that lack of musicianship was no barrier to creativity. And as a result, there was, I like to think, a certain intelligence about the music and the lyrical content. And there's one song in particular which I think I can trace my interest in the brain, in neuroscience, back to this very song. It's a rather gruesome story, but it was motivated by a true story about a murderer who accepted his guilt, but rather than face life imprisonment, he opted to be executed by a firing squad. This was in America, and so this was the law in the particular state. And he was obviously remorseful for what he'd done, and so as part of that, he decided to donate his body to medical science. And the song, I'll play you a brief snippet in a moment. The premise of the song is, if you like, a nightmare on the part of the singer who wakes up to find that he is the recipient of the murderer's eyes. And it has the wonderful lyric, "The eyes receive the messages and send them to the brain. No guarantee the stimuli must be perceived the same." Can you imagine Justin Bieber coming up with something like that? And this, let me just play it quickly. Humour me. But this, to my, 11-year-old self, it set off an interest in, how do brains work? And it made me think there's something going on in vision. We don't just see what's out there. There's somehow some process. And if you like, that was the fascination with vision and with brains that has persisted to this day. The murderer is called Gary Gilmore, as you probably gather. What can I say? T.V. Smith, the man was a poet. So it's time to show a visual illusion. This one is one that is personal to me because it's one that my wife Branka here and I came up with while we were working together on lightness perception. It's a simple, but I hope clearly visible effect whereby all of these grey patches are actually the same, but the two sets of three look qualitatively different, such that the ones in the lower left look slightly darker and the ones in the upper right look somewhat lighter. So this is really, and of course, they're actually all the same. So this is an example of the effect of of context on our perception, and this is going to be a recurring theme throughout my talk. And you'll notice that this has been termed the wedding cake illusion because we were working on this shortly before we got married, and we liked the illusion so much we put it on the top of our wedding cake. Now, and I thought I'd better add that was 2001 because the only publication from this is still in press. We presented it at a couple of international conferences around that time, and it obviously got remembered, it got sort of incorporated into the literature, and those conference papers get cited. But only recently was Branca invited to write an entry for the Oxford Compendium of Visual Illusions, and so hence the time lag. So Edward's parentage is hopefully not in doubt. So what can we learn from visual illusions? I have to thank my colleague Ben for reminding me of this quote by Helmholtz, who said that it is just those cases that are not in accordance with reality which are particularly instructive for discovering the laws of the processes by which normal perception originates. And so the idea here that is really axiomatic to the study of illusions is that the visual system is functioning in its normal way, but for some reason this stimulus is not perceived veridically, and this enables us to make some inference about the underlying neural processing. Now, this is an illusion which I didn't come up with myself. It was first reported by J.J. Gibson back in 1937, and was termed the tilt illusion. So each of these two central targets is vertical, but when you surround them by an oriented pattern or grating, then they no longer appear parallel, but instead they appear tilted slightly opposite to the orientation of the surround. Now, I was first introduced to this illusion by my late colleague, Professor Peter Wenderoth, and he shared with me his fascination for this effect. And I have to say, it's amazing how much mileage you can get out of a 70-year-old illusion when you start to think about manipulations you can use. And, that's just for anyone skeptical in the audience. They really are parallel patches of grating. And recently I was invited to co-edit a special edition of Vision Research looking at contextual modulation in vision, and I finally got to write a review on the tilt illusion. It was going to be 75 years of the tilt illusion, but wasn't quite as late as the book chapter, but I didn't quite make it in time. So the tilt illusion is another example of the effect of surrounding context on our perception. But context can be not only spatial, but temporal. Our vision can be influenced by what we have just seen. And so I'm going to show you an example of a temporal analogue of the tilt illusion. This was obviously a good year for Gibson, 1937. He had many good years, for those of you that know about vision science. In this case, I'm going to show you a video where I periodically flash up these two vertical gratings, and then I will adapt you to two oriented gratings, and then when the vertical gratings subsequently flash up, hopefully they will look somewhat oriented. And it works best if you keep your eyes on the central cross. So what I'm hoping you're seeing is that when the two gratings flash up, they form perceptually something of a V shape rather than looking properly parallel. And so this again is a repulsive effect in the sense that the perception is repulsed away from the contextual inducing pattern. Only this time it's in over time rather than over space. And so these sort of effects are what are termed in psychology of vision adaptation. And adaptation is something of an overladen term, And I'll try and be clear what I mean when I use it in this context, but typically it can mean three interrelated things. Adaptation can be a process that you can manipulate experimentally, so prolonged exposure to a particular diet of stimulation, so showing you these oriented patterns. It can also be a process because it induces changes in the underlying neural mechanisms. And it also has perceptual consequences. It changes how things look. And so typically in a psychology experiment, the experimenter controls the procedure, exposes the subject to a particular pattern, and this changes the subject's perception in a way that we can measure behaviorally, and then from the nature of the changes in perception, we infer the underlying neural processes. And I was fortunate to be invited to edit a book on this subject for Oxford University Press with my colleague at University of Western Australia, Jill Rhodes, back in 2005. So perhaps a more interesting question than what is adaptation is, what is adaptation for? Why do we adapt? In the example I just showed you, clearly you can think of adaptation as being maladaptive because it causes us to see objectively vertical patterns as oriented. But perhaps somewhat counterintuitively, there is a widespread belief, which I shared, that adaptation is actually for something. It's somehow functional. It's not simply neurons in our brains getting tired, but that it's actually trying to achieve something that's generally functionally beneficial for us. And it's only in certain artificial circumstances that it leads to maladaptive outcomes. And so, to paraphrase decades of work on the functional role of adaptation, I think while theorists disagree on the details, the key assumption is that the mapping between the stimulus and the response adapts to optimize the use of a fixed range of neural responses, so that somehow we're making best use of our neural capacity in processing visual input. But the devil, as always, is in the detail. And what exactly do we mean? What exactly do we mean by this word, optimize? And I'm going to give you a concrete illustration of a theoretical account that we put forward. And I think the novelty here isn't the theoretical account so much as actually showing how the theoretical account can predict the data. The history of adaptation was such that there were people that studied things like after effects that were superficially maladaptive, and there were people that came up with theoretical accounts of what adaptation should be doing, but the two rarely met in the middle. And so this is a very hypothetical situation, but we have a physical stimulus space, multidimensional, describing the properties of stimulus. And we have our tabula rasa, our perceptual space, with which we have the capacity to represent physical stimuli. Now, what is the best way of mapping one onto the other? Well, first of all, we want to make sure that we're in the right ballpark, that, if you like, our physical stimuli are actually represented in our space. And we can think of this as a centering operation, just shifting the perceptual space to sit over the physical stimulus distribution. But this is not going to be optimal because we've still got some perceptual states that we never experience and some that are overused. But by scaling these dimensions appropriately, we can come up with a mapping whereby the perceptual states are sampled roughly equally by all the different physical stimuli. And in this case, we can think of our perceptual system as being matched to the physical distribution of stimulation. Now, if the stimulus response mapping changes, for example, if the stimulus distribution suddenly shifts to being artificially restricted, for example, in an adaptation experiment, but also in real-world environments when there are things like changes in lighting. Then if we employ these same processes of centering followed by scaling, we can reset our original mapping. So the idea is that this process of adaptation somehow keeps homeostasis, if you like, between the stimulus and the response. Now, this is all very well, but how am I going to get from this to saying anything about the tilt after effect, for example? Well, the tilt after effect is actually quite a rich phenomenon. I showed you an example of repulsion, where if we adapt to a 15-degree grating, the perceived orientation of a test is shifted slightly away from the adapting orientation. If we use a more extreme orientation, say 75 degrees, you actually get a small attractive shift. So a vertical grating looks pulled slightly towards the orientation of the adapter. And in fact, we and Gibson back in 1937 did systematically vary the angle between the adapter and test, and you get a characteristic tuning curve where you have peak repulsion at about 15 degrees and the peak attraction at about 80 degrees. And this is something that we were able to model quantitatively in a paper with Branca and Peter Wenderoth using the model that I've just described. So let me go into a little bit of detail about how you get from the sort of abstract ideas of centering and scaling to get a quantitative model of these data. So first of all, we need to think about how to represent orientation. And here is a quote from the artist Pete Mondrian, who was very fond of oriented structure, particularly horizontals and verticals. And as he rather poetically put it, vertical and horizontal lines are the expression of two opposing forces. They exist everywhere and dominate everything. Their reciprocal action constitutes life. I think that's wonderful. As a scientist, I'd never say anything quite that bold. But the point is that vertical and horizontal lines are opposites, and that was really, they're 90 degrees apart, but they're as different as they can be. But yet, orientation is a fundamentally angular dimension. You can rotate it round, and you get back to where you started. So there's something a little bit odd, though, because if vertical and horizontal are opposites, then if you rotate an orientation by 180 degrees, you get back where you started. And so this leads to the idea of a double angle representation of orientation, where going round the clock, you smoothly change orientation, but opposites are perpendicular. So if you like, for every 2 degrees you go around the clock, you only change 1 degree in orientation. So this is the double angle notion. And the reason I introduce this is because then if we use this representation of orientation, we can apply centering and scaling to that, those operations that I've explained theoretically are what might be a good thing for adaptation to be doing. And if we take the distribution of orientations around the clock and we center after adaptation and we scale, the result of centering plus scaling is that we map our orientations around the circle onto this slightly shifted and squashed ellipse. And if we look at the effect of this on the angular position of these points, what we can see is that those points representing orientations close to the adapter are repelled away from the adapter, whereas those around the other side of the space that are close to perpendicular are actually pulled slightly towards the adapter. And if we optimize our two free parameters, we can get quite an acceptable fit to Gibson's original data. Now, we were very happy about this. But a cynical person might say, well, this illusion's been around for 60 years, and you've come up with a model that, predicts it, in inverted commas. If your model's any good, you should be able to tell us something we don't know. You should be able to predict a novel illusion. And we thought about this, and this was reviewer 2, for those of you in the audience. It's always reviewer 2. But reviewer 2 was right. So we reasoned if there is this sort of centering operation, then we should be able to shift the null point of our distribution, and we should be able to make oriented structure look like its opposite. And so I'm going to show you an example that I hope demonstrates this. It's a little bit subtle, so I'm just going to prime you first. What I'm going to show is the fixation cross and two pattern on either side with no systematic oriented structure. The time course is going to be the same as for the tilt after effect demo. I'm then going to show you these patterns. One is a starburst pattern and one is a concentric pattern. And I'm then going to flash up the original unoriented patterns. And over time, if you, again, fixate on the cross, what I hope you will see is that the unoriented patterns start to take on the complementary pattern to the adapters. So where there was a starburst pattern, it starts to have a concentric feel to it, and where there's a concentric pattern, it starts to have a starburst. Now, as I say, they're slightly subtle, so these are actually, we can objectively measure the strength of this illusion, and this is about as strong as it looks, but hopefully it will be convincing. So these are the patterns that I'm periodically going to flash up. I hope in the first instance you can see that there's no systematic orientation there. And keep your eyes fixated on the central cross. So those are the adapters. And then that's the test. And give it a few cycles just for the adaptation to build up. And hopefully, I'm not hearing gasps of amazement, but I'm used to lecturing undergraduates, so it's not. But I hope you can get a feel for the effect. Certainly, I tend to find the one on the right slightly more compelling. That seems to have a slightly starbursty percept to it, but certainly there should be a perceptible difference between the two patterns. And when we measure this objectively, the after effect is about 30% of the strength of the adapting stimulus. So these after effects that we've played around with, it turns out they're not unique to abstract patterns such as gratings and dots. My colleague Michael Webster at University of Nevada, Reno, showed that you can actually get strong adaptation effects in the context of facial identity. So we could use any two faces here, but somehow I've never found one that worked as well as this example. So this was former presidential candidates Bush and Cheney, and in the middle is a morph, basically a blend of Bush and Cheney. And if you spend 10, 15 seconds looking at Bush and then look at the morph in the middle, I think you'll find that it rather strongly resembles Cheney. If you spend 10, 15 seconds looking at Cheney and then look at the morph, it seems to resemble Bush quite strongly. And so this really caused something of an explosion of interest in adaptation. It opened it up to a much wider community in psychology. And so this got me interested in more social aspects of vision, not least of all teaching undergraduates. It seemed to be much easier to get them interested in things to do with faces than to do with dots or stripy patterns. But it led us to ask the question, well, if our perception of face is sort of plastic or adaptable, then how far can we push that? Or putting it another way, what is there about what is there about faces, for example, that is inviolable? What do we expect of a face that can't be changed? And this illusion, which I... that's the sort of reaction I like to get. That, there's something dissonant about this image. There's something more dissonant about this image than if it didn't have 2 eyes and 2 mouths. And that seems to me to be an illustration of the fact that we have strong expectations about the basic structural properties of a face that can't help but influence our perception. I mean, people have done this sort of manipulation with cars, with headlights and radiators, and it looks interesting, but it doesn't have the same sort of visceral effect as doing that to a face. So one of our current lines of research is to try and understand, if you like, what aspects of face perception might be plastic, and what aspects of face perception are actually sort of unchangeable or hardwired, if you like. So that really leads me on to our future work. Having got interested in social vision, I was pleased to be approached by a team led by Mari Belanaki at UNSW Art and Design, who are interested in putting together a facility for the study of human-android interaction. The android is the one on the right, in case you're wondering. This is Edward. He's here in the second row. And we've been successful under Mari's lead in getting ARC funding to put together a facility where we can study the interactions between humans and androids. So this, to my mind, is an exciting avenue for social vision. Androids are very good avatars, if you like. If you want someone to have a completely expressionless face, it's very hard for anybody to actually do that, but androids seem to be able to pull it off wonderfully, which is very useful for sort of experimental control. And it's the case that I think worldwide, but particularly in Japan with their aging population, there's an increasing practical interest in using androids in roles where they interact with people. And so they can often have quite a strong negative reaction, what's known as Uncanny Valley, whereby there's something, you're almost sucked into believing that this is a human, and then it does something jerky or machine-like, and it's a very creepy experience. And it'd be interesting to understand how that works and how ultimately we can try and move beyond that. Another future direction, although really it's something we've been doing for 10 years, is looking at what's actually going on inside the human brain when we experience some of these illusions and after effects. And to do this, we employ magnetic resonance imaging. And hopefully that's something that's going to be ongoing, although if recent funding outcomes are anything to go by, we might be reduced to magnetic resonance imagining. This slide does have a serious side. It reminds me to acknowledge the assistance of many people in the lab. When you go to the scanner, time is money, and so it's important to get all the bugs ironed out as thoroughly as possible. And one of the things we've been doing is trying to track people's eye movements while they're in a scanner. And apart from the inevitable vibration, you're also tracking through a mirror, which causes a double image. And so many hours were spent in the lab calibrating and setting up the eye tracker and making sure that this nice wooden tripod was actually entirely wooden and didn't have any ferrous bits that were going to fly out. And so, this really brings me to my acknowledgements. First of all, thanks to the funding organisations that have supported my research over the years, and a big thanks to all my collaborators, particularly lab members over recent years, many, but I apologise, not all of whom are represented here. Thank you very much.
Okay, good evening, good afternoon. First, I want to say thank you to the university for giving me the opportunity to give this talk, and secondly, thank you for coming to listen. So I'm going to try and pick up the baton and move from visual illusions to what's become known as cognitive illusions. But I have to say that in thinking about what I was going to talk about for this talk, it was quite a challenge because it's not a typical talk. It's not a conference paper, it's not a public lecture, it's my family are here, my colleagues are here, so it's hard to know exactly how to pitch it. So in part, I was inspired by kind of dinner time conversations that I've had with the family. And a good example of one of those is the following, with my son James, who's sitting down here playing with my PhD hat. And it went something like this. So James said, "So you're a professor, right?" I said, "Yeah." So he said, "So you know pretty much everything." To which I said, "Well, not everything, no." "So what do you study then?" "Well, I study how people think," I said. To which James asked a very good question. "And how do people think?" To which I answered, well, lots of different ways. So I shall get back to those lots of different ways in a moment, but as is customary, I'll do a little bit of personal background. So I don't think I can identify a light bulb moment to do with punk lyrics like Colin could. I think my fascination with psychology just came from an increasing inquisitivity about how we learn, how we understand the world, how we make judgments and decisions in the world that presents itself to us. I think fostered by interests of my own parents. So I studied biology, physics and chemistry for A-level in high school in the UK, and then I went on to the University of Nottingham and did an undergraduate degree in psychology. After that, I didn't go straight on to academia. I wanted to do something different. I went to Japan for a couple of years and taught English while I was in Japan. But while I was there, I felt that there was still more I wanted to do in psychology, more I wanted to study. And I decided that I would like to go and study at UNSW. Now, this was a decision that was not purely driven by academic interests, I have to admit. So I did have a contact. I had a contact through my honours supervisor at University of Nottingham, who knew someone who was on the staff here at UNSW at the time, Professor Jim Bright. But I did have ulterior motives. So I grew up in the southwest of the UK, and I started surfing at quite a young age. I used to surf in conditions like this. And then when I went to Nottingham, I learnt how to scuba dive, and I learnt to scuba dive in this quarry, which is called Stony Cove in Leicestershire, freezing, and where if you saw one fish on a dive, it was a result. So I didn't know all that much about the Australian academic scene, but I did know that Australia had waves like this and dive locations like this. So I duly came to UNSW, and alongside studying for my PhD, I did get involved in the scuba diving club, and I in fact became the president of the scuba diving club. And here is a excerpt from the student paper, the Tharunka student paper at the time. This is from 2000, May 2000, just as I was coming into the third year of my PhD. I had a great time in the underwater club, in the diving club. It's in fact where I met my wife, Sandra, who's sitting at the front here. We got engaged on Northwest Island on the Great Barrier Reef, so I got to dive on the Great Barrier Reef. And then the rest is history. This is all of us earlier this year, and we're all sitting at the front here. So, following, just to complete the circle, following UNSW, we then went back to the UK. I did a postdoc at UCL, of which more a little bit later. A postdoc also at Uppsala University in Sweden. And then when it started to get too cold for us there, we came back and I joined the faculty here at UNSW as a lecturer in 2004. So that's a bit of the background. So getting back to this issue of cognitive illusions and visual illusions. So here's that quote from Helmholtz that Colin's already shown us, and here's another couple of visual illusions just in case you haven't seen enough already. This, lots of you have seen this one. This is called the Mullah liar illusion. This line here is the same length as this line here, even though it really looks very different. This is Roger Shepard's illusion, where this area of this table is the same as the area of this table, even though however much you look at it, it really doesn't look that way. And as the Helmholtz quote illustrates, he says it's just those cases that are not in accordance with reality which are particularly instructive for discovering the laws of the process by which normal perception originates. The way that we link this to cognitive illusions is that there is a claim that we can change the idea of perception and telling us about perceptual processes to thinking about cognition and cognitive processes. So can situations in which we make errors or fail to see the right answer in a situation, we succumb to some kind of illusion, can that tell us about the laws of the processes underlying normal cognition? And that's a claim that I want to explore in this talk. So this is the audience participation part. I'm not going to get you to put your hand up, but I would like you to just think about the answers to these questions that I'm going to pose for you. And unfortunately, rather than just looking at them, you have to think for the answers for these ones. So, and for many of you in the audience, these will be kind of old chestnuts that you've seen many times, and it will be not news. Some might be more novel for some. So the first one is perhaps what's become one of the most famous examples of a cognitive illusion. This was introduced by Amos Tversky and Daniel Kahneman probably about 30 years ago. Many of you might know that Kahneman went on to win Nobel Prize for economics for the work that he did with Amos Tversky. So this question, this problem, it goes as follows. Linda is a 31-year-old, single, outspoken and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. And then you're given a question. Which of these is most probable? Which is the most probable alternative? Number one, Linda is a bank teller, or two, Linda is a bank teller and is active in the feminist movement. Now, don't tell me what your answer is, and don't discuss with your friends, but just think about what you think the answer to that question is. Okay. Everyone done that? Good. Okay. Next one. Here's another type of question. This is one that involves a simple dice game. So imagine that you've got one die in front of you. It's got 7 black sides and 3 white sides. And then we're going to roll it 10 times, and you've got to predict what colour is going to come up on each of these rolls. And you're going to get $1 for every time you get that prediction correct. Okay, so what you've got to think about is, what am I going to predict on roll 1, roll 2, roll 3, blah, blah, blah. Okay, 10 rolls of the die. What are you going to predict? Again, think about your answer, make a mental note, and then we'll go to the last one. Okay, so the third one, it's not really an illusion, but it's a kind of question that people like me love asking participants in experiments. And it's the following. Which of these 2 options do you prefer? $30 for sure, i.e. 100% chance, or a gamble that offers an 80% chance of $40 and a 20% chance of nothing? Again, which one are you going to go for? All right, so those are 3 different simple questions, but the question is, what do they tell us about the way people think? Do they elucidate anything about the underlying cognitive processes that people engage in? Well, let's go to the first one, the Linda problem. So the crucial thing here is this word "and." Okay? Now, this problem, which many of you will know, is an example of what's become termed the conjunction fallacy. And the conjunction fallacy basically just says that 2 conjoints cannot be more probable than one of those conjoints on its own. Okay? So the correct answer here is 1. Linda is a bank teller, not the bank teller and active in the feminist movement. A picture like this usually convinces most undergraduate students, here's the overlap between bank tellers and feminists. Here are the bank tellers, here are the feminists. Okay? So that's the correct answer in this situation. It's probably best captured in this quote from Stephen Jay Gould, the late paleontologist and science popularizer, who says, "I'm particularly fond of this example because I know that the conjoint statement is least probable. Yet a little homunculus in my head continues to jump up and down, shouting at me, "But she can't just be a bank teller. Read the description." And many of you might be sharing that intuition now. The second example, going to the dice game. So here's a question: will the die roll a black or a white? Now, I posed this question again at dinner the other night. My 11-year-old Zoila, who's sitting here, said, "That's easy. You just say black every time." Now, many of you might have picked that as the right answer, but surprisingly, perhaps, undergraduates at UNSW will quite often engage in a set of predictions that look something like this. So they'll say black most of the time, but they'll say white a few times as well. Why do they do that? Well, they're trying to match the probabilities that they know exist in the world. They're trying to capture those rare events that will happen. But if you do that, then and you come to my experiment, then I'll pay you something like $5.80, which is what you would get from the probability matching. If, on the other hand, you do what you should do and predict black on every single roll, then I'll pay you $7. Okay. So again, the question is, why do you do that? Why do some people engage in that type of behavior? And then the last one, the $30 for sure, or the gamble offering 80% chance of 40, 20% chance of nothing. Again, this is not really an illusion, and I'm sure many of you can work this one out. But if you think of this in terms of expected value, so some sort of calculation of the long-term outcome, then the expected value of A, you know, is $30, but the expected value of B is 32, 40 times the 0.8. So in one version of thinking about what rational choice means, then you should pick B over A. Okay, so these are sort of simple examples of the kinds of problems that you can give people if you're trying to understand the processes that they're engaging in when they're making judgments, making decisions. What do we learn from these? Well, what I want to try and argue is that, yes, these are useful insights and so-called illusions, but we can go beyond them, we can see beyond them. And I think that a lot has been written about what these things tell us, and I just want to kind of give my perspective on it, I suppose. So do they elucidate a cognitive process? Well, I think they do, but I don't think they really sort of nail down exactly what's going on here. And there's been a lot of people that have debated and criticized this. For example, in the Linda problem, well, what do you mean by probable? Do you mean in terms of probability theory, or do you mean the way that I would usually use the word in conversation? If it's the latter, then it's not really an error. Which leads to the next point. Are they really errors? Well, it depends. It depends what you think the right benchmark is for assessing my ability to make this particular judgment. What I think they definitely don't show is that we're hopelessly irrational. And I think a lot of the movement, the heuristics and biases that came from these types of experiments emphasize the sort of cognitive cripple idea, that we couldn't really get anything right and that we were hopelessly irrational. And I don't think they show that at all. I think they show that psychologists are very clever at coming up with examples that people will slip up on. A particular bugbear of mine is that people would say, well, if your explicit thought is so poor and you can't really think through the implications of these things, then we should just defer to some kind of unconscious system that produces the answers for us. I think that the empirical rather than the anecdotal evidence for that sort of claim is very minimal. Can we learn to see beyond them? Well, yes, we can. I think if you set up the environmental contingencies correctly, I'm just looking at my colleague Andreas now, if you give the right incentives in these problems, then often some of these illusions can disappear. But what are the implications of them? Well, the implications are many and varied, and I want to talk a little bit about those last 2 points. Can we learn to see beyond them? What are the implications? Now, if you want a completely kind of full story of this account, then I can recommend this book. Now in its second edition, and this really sort of describes that kind of account whilst covering a lot of the literature on the psychology of judgment and decision-making. And I was particularly pleased with this second edition to get an endorsement from Daniel Kahneman, where he gave us a good endorsement, despite the fact that we're not really aligning with his views all the way through the book. So to give some slightly more specific examples of what I mean about how you can change the conditions and kind of overcome these perceived apparent errors, I just want to show a few examples, a few kind of experimental data. So here's one that relates to the dice problem. This is a question that we asked a former PhD student of mine, Kristen Schultz, and I asked this question. So we give people this simple dice problem, but we ask, well, can we change the expectancies that people have in arriving at this answer? In other words, a tendency to probability match rather than maximize, just by giving them a chance to sit in some groups and discuss the different ways that you could respond. And what we found is overwhelming evidence that the answer for this was yes. So what's plotted here is the proportion of dominant color choices. So in other words, how many times did they say black for 50 rolls of this die in an experiment? And what you can see is that if you sit on your own as an individual and think about it, try and come up with it, or if you sit on your own as an individual and we give you a bit of extra time to deliberate, then you get to a point somewhere between probability matching, which in this case is the 70%, so saying black 7 times out of 10, and maximizing, which is up here. But most people are sort of over-matching. In contrast, if you put people in a little group of 4, just randomly assigned into 4 people, and give them a chance to discuss, well, what should we do here in order to make the most money, then probability matching disappears and the vast majority of groups strictly maximize or get very close to it. So just giving people that opportunity to think a little bit more about the problem and discuss and come up with strategies alleviates this so-called erroneous tendency. Another example, using again the same paradigm, when we give people a chance to learn in this problem, we can also reduce probability matching. This is interesting because normatively there isn't really anything to learn in this problem. You're told what the probabilities are at the outset. You know what you need to know in order to answer optimally. And yet in this experiment with my colleague Tim Rako and others, we showed that if you give people feedback, so this again is the proportion of dominant color choices, we made our participants make 300 predictions in this game, so 50 trials in each of these blocks. Feedback here refers to just seeing the outcome of the roll of the die on each trial. So you actually see whether it comes up black or whether it comes up white, which is irrelevant because you know what the probability of it coming up black or white is. And yet that reinforcement, if you like, of the feedback shows that people do learn to approach maximization, which is up here, whereas if you don't give them that feedback, they flatline at probability matching. So you have to kind of overcome that initial misperception in order to get people to make a better choice. Okay, one example following on from the risky choice, the sort of gamble choice that I discussed. So the version of the choice that I gave you was this. Which do you prefer, 80% chance of 4 or nothing and 100% chance of 3? Now, when you see the information in this way, you have, again, all the information that you need in front of you to make the decision. And in recent literature, this has become termed a decision from description. I'm describing the probabilities and the outcomes to you. But there are other ways that we learn about probabilities and outcomes in the world. Often we don't have that kind of privileged access to the exact probabilities, the exact amounts. And one kind of paradigm that I've done quite a bit of work with recently has become known as this decision from experience. And here, the participant is actually facing exactly the same choice, but they have to learn about what that choice is. So they don't know at the beginning of the experiment what A offers or what B offers. But they can take samples, they can have different trials where they select from these different options, and they might find out on one trial that A gives you 4, then B gives you 3, and so on and so forth. They might see the 0 case come out in the 4. And across the trials then, these buttons are programmed to deliver 4 80% of the time and 0 20% of the time, and people have to learn that from experience. And the question is, well, what happens to people's preferences as a function of these different ways of finding out about probabilities and outcomes? And it's I think, an interesting and somewhat surprising result. So here's some data from a paper with my colleague Tim Rako. This is just the percentage of participants who choose one or other option. So these are actually kind of redundant columns here because one is one minus the other. But So in description, when you know exactly what you're facing, then the overwhelming majority choice is for the sure thing, which maybe reflects what you thought when you were given that option to begin with. People don't like this one. However, if you learn about those probabilities and outcomes via experience in that trial-by-trial accumulation, then you get a reversal of those preferences. So now people tend to prefer this 80% chance of getting 4 rather than the sure thing. Why is this happening? Well, one interpretation of why this is happening, or one thing that seems to be going on, is that this rare event, the 20% chance of getting nothing, seems to be treated differently in the description case than in the experience case. So when it's described to me, that 20% seems like something that I really want to avoid, something that I don't want to have to deal with. I tend to overweight it in the jargon term. In experience, on the other hand, it seems to get underweighted. We seem to be more willing to kind of ignore that 0 outcome, and we'll go with what's best most of the time, which in this case is the 4, which is better than the certain 3 on the other side. So what are the kind of implications and applications of what these are quite simple problems. They're relatively straightforward experiments, but I think that they do have implications and applications to lots of different issues outside of the laboratory. And I've been fortunate over the last few years to be involved in projects with many different colleagues, some of whom I'm glad to see are here today, where we've tried to apply some of these insights from judgment and decision making to, as I say, problems outside the lab. So some of these include understanding how people deal with probabilistic evidence in forensic science context. So if you've got a DNA statistic or you're trying to reason about the probability of a fingerprint, how do you integrate these wild probabilities that you sometimes see? I've also been fortunate to be involved in now 2 linkage projects with UniSuper, looking at how people make superannuation decisions, how we can engage people more in superannuation choice, how they think about how they are going to fund their retirement. I've also done work with colleagues over at the University of Sydney and a PhD student, Carissa Bonner, on medical decision making, particularly communicating cardiovascular risks. I was involved in a project where we were looking at the concept of a heart age, telling people how old their heart was relative to their actual chronological age and how best to communicate that. And then lastly, I've been increasingly involved in work on climate change and the psychology of climate change communication. And this is something that I've become increasingly passionate about and very keen to try and cultivate the links between what I see as insights from psychology with trying to get better communication, better understanding of this major problem that we all face. Just to give you a very brief flavour of that, we had a paper that just got published in Nature Climate Change just last week, where we tried to build on some of these insights from how people treat rare information, so there's decisions from experience where you tend to underweight this rare event, and translate it into an experimental scenario in which we simulate people experiencing disasters caused by severe weather or something like that, and see how that plays out in terms of their risk perception and their choice. I've also tried to publish papers that connect the psychological literature with, say, the work in physical climate sciences. So this is published in the Bureau Bulletin of the American Meteorological Society, and other environmental areas, environmental management and so on. And I'm also passionate about getting this message outside of the journals and into the wider public, either through videos that I've been involved with or writings on the conversation that I try and do fairly regularly. And I'm very pleased to see that UNSW is going to be hosting this climate change forum in the coming weeks. Okay, so that probably leads me to my acknowledgements, my acknowledgement that this is, of course, a highly collaborative effort. According to Scopus, I was surprised to find out that I've got almost 100 co-authors worldwide. I didn't go through to check whether that was accurate. These are the funding bodies. I've been very lucky having funding from all 3 of these bodies. And although this is a very collaborative effort and there's lots of co-authors and it seems odd to pick out one person, I do just want to return to the postdoc that I did at UCL, which was supervised by Professor David Shanks, who I think has become a bit of a mentor for me throughout my subsequent career. And I just wanted to acknowledge his involvement both in the book that I mentioned earlier and also this paper that came out a couple of years ago, where we really took a good look at this notion of unconscious influences on decision-making, this idea that we should give up on explicit thought and rely on the unconscious. And the clue is in the title, A Critical Review. And lastly, I guess the thing I find most enjoyable about this job is being able to share these ideas and have these discussions with other people who have similar passions and interests. And I haven't got pictures of everyone, but I have got some pictures of the postdocs that have been through the lab recently, including Manos here, who just arrived about 3 days ago, so a welcome to him. These guys have all been postdocs over the last few years in the lab and have gone on to great things. My PhD students, graduated ones and ones currently studying. Arthur refused to be shown up on the screen, so he's incognito here. But it's been a real privilege to work with all of these people, and I'm very proud to have done so. And even all of the honours students that I've supervised, I haven't got pictures of all of them, but they bring back a variety of memories, shall we say. So with that, I shall finish and say thank you all for coming along. Thank you.
Thank you very much for that, Ben. So my name's Merlin Crossley. I'm the Dean of the Faculty of Science here, and it falls to me to thank everyone and to close the evening. But as I do so, I'll just share a few reflections I have about Ben and Colin over the times I've worked here. And there's a notable thing. These professorial lectures, we celebrate people who were either promoted or recruited in the last year or so. And Ben and Colin are different. Ben was promoted to professor, and Colin we recruited from a nearby university. Now, it's quite interesting, actually, because I've known Ben since he was about the age of the photo of Colin. So he hasn't changed much. But the promotions, you learn a lot about people in promotions committee. And our committee works very hard to ask exactly the right question. And the question that we've never had a question which was quite as good as the question James put, which if you want to be a professor, you know everything, don't you? And that's the sort of question, and we ask a question a bit like that to Ben, and he certainly gave me the impression he did know everything, and that's how he got promoted. But I wish James had been on the committee, because that's the sort of question that we like to have. Now, so Ben was promoted, and we then also promoted him to deputy head of school in the School of Psychology. But I want to talk about Colin, who's served on the promotions committee. As soon as we appoint people, we put them straight on the promotions committee if we can. And when Colin appeared on the promotions committee, on the right side of the fence on the promotions committee, he said to me, we went round the table, introduced everyone, and Colin said he was a psychologist. But he said, don't worry, you don't have to be nervous of me as a psychologist, because, people are often nervous because psychologists are constantly analysing you. He said, I'm not your average psychologist. You can trust me. I work on illusions. Now, this started me thinking. So all my time at UNSW, the first message, I've been here 6 years, my first message that I got was we have the greatest psychology school in the Southern Hemisphere. I have seen I know the teaching quality is spectacular. The students love it, and the number of students is always increasing. I keep my eye on that. In research, the number of grants, number of fellowship winners, the people we recruit from other universities, it's absolutely fantastic. The whole Matthews Psychology Tower, which I believe is one of the tallest buildings in the whole university, is full of excellence. At least I thought it was. Now, I don't know if I can believe my eyes. I don't know if I can believe my ears, and I have absolutely no way of knowing, but I suspect it is. And one of the reasons that makes me think it is because as a dean, I find it hard to read, I find it hard to think, but I can count. And this is one of the largest audience we've had. So I know that the psychology school has a great reputation, they do great things, and I'm prepared to accept they're one of our strongest schools. So I thank you all for coming tonight. I thank our two speakers, and please join us for some drinks and some nibbles out in the foyer. Thank you very much.